In this lesson, we're going to look at rational exponents. Your essential question says, how do you transform rational exponents to a radical and vice versa, meaning a radical to a rational exponent. Please make sure your notebook is set up. Okay, so we have a little bit of vocabulary here that I wanted to talk about, just to make sure we know what the different things mean. So as we deal with rational exponents, first thing is we might see some directions that say write it in exponent form. And this just means write the problem with exponents. Write the problem, write the answer with exponents. For example, 5 to the third power. Okay, that's writing it with exponents. Then it's going to say, ask you to do something right in radical form. So it might say write with, when it says write in radical form, write with a radical sign. Now you've talked about radical signs, should have talked about radical signs in the past. A radical sign is just things like your square root signs. But there are other roots besides square roots. So like normally we have, here's square root. We know that this is an understood 2 right here. We have cubed roots, or we could have fourth roots. Okay, those are all examples of radical signs. Then we're going to be, obviously our whole topic today is talking about rational exponents. And so mainly what we're looking at is we're looking at exponents that are fractions. We know that a rational number is any number that can be written as a fraction. And so, like I said, primarily our focus is exponents that are specifically fractions. And so here's an example. 2/3 is our rational exponent. I mentioned roots just a second ago, and so I do want us to understand that there are square roots. That is probably what you are most familiar with. You'll be getting to work with other kinds of roots as you move forward. Square roots look like this. Again, remember, I told you that this is an understood 2. We don't write a 2 in this little nook, but that would be the square root. And so just to give us an example, 8 is the square root of 64. And the reason 8 is the square root of 64 is because 8 times 8 is 64, right? We also have other kinds of roots, like I mentioned. So an example would be the cubed root. Okay, cubed root would look something like this, where it has a 3 in the nook. And I want to give you an example. 2 is the cubed root of 8. Because 2 times 2 times 2, it takes 3 2's multiplied together to give me 8. Okay? So just a little vocabulary there so that we know what we're talking about. Okay, in this first part, it says to evaluate. And so all we're doing here is we are evaluating each of these numbers with our calculator. Okay? So I am going to pull up Desmos because I think that will be the best type of calculator to be using. I'm not sure how well just your basic phone calculator is going to do. So if I want to evaluate, if I want to calculate 6 to the 1/2 power, I'm going to type in 6. I'm going to make sure that I choose my exponent key that's going to allow me to put a fraction. So I'm going to do 1 divided by 2. Okay, and so you can very easily see that 6 to the 1/2 power, if we round this, it would be 2.45. Okay, we are going to have to round that. Okay, the second one, again, we're just practicing inputting this to our calculator. -3 to the 2/3 power, this is going to be negative. So I'm going to take that out. I'm not even going to worry about putting in the -3 to the 2/3 power, -2.08. So really important, really need to make sure that you take the time to do these in your calculator and make sure that you can get these actual answers. -64 to the 1/2 power. I'm going to type this in exactly how I see it. I'm going to put parentheses, -64, close my parentheses, to the 1/2 power. And notice that says this is undefined. And we're going to talk about that in just a little bit. That is undefined. Okay, and then this last one. Okay, so I'm not even particularly sure how we do this with Desmos. So let's double check this. So I'm going to type in negative, and then I have a cubed root, but it doesn't look like, let's see if I have other roots that I could do. Okay, so let me go back. On Desmos, I'm going to go to functions. See how this says functions? I'm going to go to functions, and you see this option right here where it's got an N? That's going to allow you to put that 5 in the little nook. Okay, and then I can type in 1024. And I forgot to put the negative sign out front, but because it's out front, that just means, well, let's see, maybe I can add it in there. There we go. Okay, so all that does is change it to -4. So not going to probably have a lot of problems like this year, but I just want you to see it and see that's how you would do it in the calculator. Okay? Okay, so here we have this rational exponent rule. Okay, this is our rational exponent rule, and it looks really, really confusing, but I promise it's not as bad as you think. Okay, so right here, this first a to the m over n, that would be our exponent form. Okay, and then this is just kind of showing the process of how you get there, but I'm going to show you that it's much, much easier. This is your radical form. Okay, and so what I want you to see is that the a value is your base from exponent form, and it is the inside of our radical. Later on we're going to learn that that's called the radicand. Okay, it's the radicand, it's the base. The n is, notice, is the denominator in our exponent, or it is the root. It is the root that goes in our little radical sign. I like to call it the nook. It goes in the nook. Okay? And then we have our m. It is the numerator in our exponent. And then in radical form, it is the exponent. Okay? So make sure we have that written down. So the first thing we're going to do is we're going to take our expressions from exponent form to radical form. So I'm going to start, I'm going to put my radical sign. Okay. Notice 15 is my base. It is my a value. So it goes inside. Your fraction, your exponent, remember, is m over n. So the n, the 3, is our root. It goes in the nook. That's our nook. And then the m is 1, or our exponent. Now, what I'm going to show you here is just, we would put a 1 there, but most likely this is how it would be written, because ones are understood, and we have to start recognizing that we should not be writing that with a 1 there. It's not wrong, but it's technically not the correct way to write things. Okay? Okay, let's look at the next one. So again, I'm going to draw my radical sign. This is my a value, so it goes inside. My fraction is m over n. The 5 goes in the nook. The 3 is my exponent. And that's it. That's radical form. Okay? Here's another one. 125 to the 2/3 power. Okay, write your radical sign. 125 is my a value. M over n. The n goes in our nook. And we square it. Now, one thing that we talked about is that we can take our calculator and we can actually calculate this. But I want to show you we could actually calculate this, we could evaluate this all on our own if we wanted. So if I wanted to take this a step further and evaluate it, 125 actually happens to be a perfect cube because 5 times 5 times 5 is 125. So the cubed root of 125 is 5, and then 5 squared is 25. Okay? So if you did that with your calculator, you would see that it's the exact same thing. Okay, so now let's go from radical form to exponent form. Okay? So we know that our base is 8. And then remember, the 5 is in the nook, so it's our n is in nook, and this is our m. And so our exponent, remember our exponent is supposed to be m over n, so all I have to do is write 8 to the 4/5. Okay, this one, our base is negative 21. 5 is in the nook. This is our m. And so I write m over n, 6/5. That's it. Okay, last example is a volume problem. The volume of a cube is volume equals s cubed because all the sides are the same. So if I know the volume is 216, how would I undo a cube? I would undo a cube by doing the cubed root. So all we have to do is the cubed root of 216. And so the one side is 6 centimeters. Okay?